All right, so the last video, I guess that was video number 2. This sort of is what we went through in that. We have this general formula. Anytime we want to find, well, what's the nth term? Nth being like, well, n is a variable that can change. When we're talking about the 9th term, it's like, well, what's the term when n equals 9? If we're talking about the 21st term, well, what's that term when n equals 21? So we always need to know the starting point, t1, the first term. We need to know, well, what term are we talking about? If it's the 16th term, n equals 16. If it's the 5th term, n equals 5, etc. And then d is our common difference. So let's do a couple of these examples. So I'm just taking it from like page 518. 518. So with this sequence, -8, 2, 12, 22. Well, I don't even need to know that much about this, and I can still, like, even with just four terms in the sequence, I can pretty much figure out how this sequence is going to go for the rest of things. But basically, T1, that's always got to be that starting point. So that must be -8. The common difference, well, what's it going up by? One way of thinking about calculating the common difference, which this is just something from the book, but you could think about it as d equals tn minus tn minus 1, which basically just means take any term, and then subtract the term right before it in the sequence. So, like in this case, let's say I take, because just to be clear, you know, the starting point always has to be T1. So that means this is going to be T2. This is going to be T3. This is going to be T4. So I can take any term. If I'm taking T4, let's say I take T4, which is 22, that means I want to subtract the term right before it, which is T3, which is 12. So that means D equals 10. I would get the same thing though, because 12 minus 2 is 10. 2 minus -8 is also 10. 12 minus 2 is 10. 2 minus -8 is also 10. So you would get, for an arithmetic sequence, you're going to get the same common difference every single time. So we have 2 pieces of information. And yeah, we could pretty much calculate any term now. If someone says, oh, determine the 40th term in the sequence, that's going to be n equals 40. And we already know that d equals 10. And the starting point is -8. So you could plug that into your formula. T40 equals -8 plus 40 minus 1 times d, which is 10. And you could figure that out. -8 plus 39 times 10 negative 8 plus 390, 382. So from a limited amount of information, you really only need to be able to figure out, okay, well, what's that common difference? And what's that starting point? And then you could technically find like many different values. What about if we look at page 519? Consider the arithmetic sequence which is -6, -1, 4, 9. Okay, well, my starting point definitely has to be -6, because I can see that's my starting point. Common difference, well, I always have to just take one term and minus the one before it. If I take this one, I'm going to minus this one. If I take this term, I'm going to minus this one. If I take this term, I'm going to minus this one. And I should get the same common difference every time. So let's show that. So 9 minus 4 equals 5. 4 minus -1 equals 5. -1 minus -6 equals 5. So common difference is constant for all arithmetic sequences. What I mean is that, like, all arithmetic sequences, their common difference stays the same in any particular arithmetic sequence. If the common difference is 5, it's always going to be 5. Yeah, so the question, it says, determine the value of the 12th term of the sequence. Determine the value of the 12th term in the sequence. Well, that means n equals 12. So T12 equals T1. So I'm using the formula Tn equals T1 plus n minus 1 times d. I'm always going to be using that formula in these situations. But then I plug in what I'm actually dealing with here. T1 is -6. N has to be 12. Common difference is 5. So -6 plus 11 times 5, -6 plus 55. T12 equals 49. So yeah, that's how you can determine that. So here's another question from page 519, which is kind of interesting. Find the number of terms in the arithmetic sequence here. So basically, some arithmetic sequences go on forever. Those ones would be called infinite arithmetic sequences. And those are like the ones we've kind of seen before. Like, for example, from the previous page, -8, 2, 12, 22, they just kind of dot, dot, dot. It's just going to kind of keep going forever. Something like 15, 10, 5, 0, dot, dot, dot. That sequence can just continue forever. The previous question, it could continue on forever, but other sequences have a defined end point. These would be called finite sequences. And we can see here, like, see how, so we have a starting point of 3, we have a couple terms, this dot, 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 so the sequence continues, but we have this last value, negative 117. So that actually tells us that, like, it's not just trailing off forever, infinitely. There's a finite, there's a place where this sequence actually ends. And so let's, like, look at what if we want to know the number of terms, well, what that's actually asking us is, like, which term in the sequence is negative 117? What's the n value? What is the value of n when Tn equals, because if we know that, if we know what the value of n is when t equals 117, then we know how many terms there are in the sequence, because that's the endpoint. So let's just remember that our general formula is Tn equals T1, the first term, plus n minus 1 times d. And so in this case, the question is asking us, find the number of terms. So we're actually going to be solving for n. In this case, n is our unknown value, which can be determined algebraically. Because as long as we only have one unknown, we're pretty much good. So, like, to rephrase the question, we want to know the value of n when t of n equals negative 117. So taking our general formula, let's start plugging stuff in. Well, when Tn, we want to know the value of n when t of n is, or when Tn is negative 117. So when Tn is negative 117, T1, that's always going to be the starting point, right? So what was the starting point here? It was 3. N minus 1, again, n is our unknown, so we can't really substitute anything there. D, common difference. Well, what's the common difference here? Looks like we're going down 4, so negative 4. Negative 4. So at this point, I just have to, like, do my algebra steps, which could be a bit tricky, but I think it should be okay. You might want to think about this separately, and you're going to have to kind of, like, distribute, right? Like, maybe I can change the order of this to make a little bit more sense, but I'm going to be distributing. So negative 117 equals 3 plus negative 4n plus 4. Negative 117 equals 3 minus 4n plus 4. 3 plus 4 is 7 minus 4n minus 7 minus 7 negative 1, 2, 4 equals negative 4n. Divide both sides by negative 4. N equals, n would equal 31. That makes sense. Yeah, 31. So yeah, we can, whatever our unknown is, as long as we just have one unknown of this formula, we can solve for that one unknown algebraically.